Hi, this is Mr. Miller, and this short video is to introduce you to how to use a normal curve. Normal curves appear in a lot of different ways in statistics. It's something new, so there's a lot to learn, but once you get used to it, this is not going to be a problem at all for you. So let's get going. First, a normal curve is a hill-shaped curve, kind of like these. There are four normal curves here, and they're used to approximate symmetric data. So if you give us the mean and the standard deviation of your symmetric data, we can find a curve that will be good to approximate it with. All right, so some normal curves are skinny, some are spread out, but they all have this kind of hill-shaped kind of feature. All right, well, I want to do a quick example to show you how we use this curve to model symmetric data. So here's a problem. It says the amount of juice dispensed from a machine is normally distributed. This right here, where it says normally distributed, is telling us that we can use a normal model to approximate the data. That'll give us a good estimation of the results. So the juice dispensed from a machine is normally distributed with a mean of 10.5 and a standard deviation of 0.75. Here's the normal curve that fits this data. It's centered around the mean, 10.5, and we can see the standard deviation also. It's what these tick marks are going up by. So about right here, above the first tick mark on the right of the mean, this distance right here in a normal curve is 1 standard deviation. So we see that the x-axis is marked off in standard deviations, and the curve is above it. Now, we want to find what percentage of dispensed juice that is less than 10 ounces. So the juice machine dispenses juice, and on average it's 10.5 ounces, but what's the probability that it's 10 or less? Okay, this is how we use the normal curve. 10 would be about right here on the x-axis, and I'm going to draw a line up to the curve. Now the way this works is that the percent of times that juice is filled to less than 10 ounces is equal to the area under the curve from the value of 10 and to the left and below. Okay. So if I want to know what's the probability that it's filled less than or equal to 10 ounces, that would be the area under the curve to the left. Now, the whole area under the curve is 1, representing 100%. This area will be less than 1. It's less than a half. Okay, so that's great, but how do I find this area? Well, that's done in a lot of different ways. A graphing calculator can do it. There's a lot of programs to do it, but we're going to use this website here. This is called the Normal Distribution Calculator. It's saved in our Google Classroom. And what we do is we enter the mean, 10.5. We enter the standard deviation, which was 0.75. And once I do that, notice that the x-axis under the curve is labeled like the one I showed in the slide. The mean is 10.5 and it's going up by standard deviations. All right, we want the area that's below, so I click below the value of 10. And I hit calculate, and you may have a hard time seeing this right here, but it tells me the area right there. It's 0.2525. So this area right here that I shaded, whoops, I didn't mean to move the whole area. This area I shaded right here is 0.2525. That's the decimal form of the percent. So the actual percent is 25.25%. All right. This is the same example. We have a machine that's dispensing juice for us. Same mean and same standard deviation, same normal curve. We're just going to answer a different question. This time, we want to know what is the percentage of time the dispensed juice is between 9.75 and 12.0. 9.75 is right here, and 12.0 is right here. We want to know the percent of time it's in between those values, so it's the area under the curve between those. So this area right here, whatever that is, that represents the percent of time it's filled that much. So, okay, I'm going to go over here. Sorry, I have a little trouble. And use our calculator. We want to know the percent of time it's between, let me see, 9.75 and 12. So between 9.75 and 12. So it shades the area, draws a normal curve for us, and labels the x-axis, shades the area we want, and it calculates what that area is. It's 0.82 approximately. This area right here is 0.82. Okay, so our final answer is 82% of the time. It's going to fill it between those two values. All right, so we have one problem where we're finding the area less than the value, one problem where we're finding it between two values. We can also find greater than a value. So again, same example, but this time, what is the percentage of time the dispensed juice is greater than 12? So here's 12. I'm going to draw a line there, and we want greater than 12. So it's the area under the curve for values of x that are greater than 12. So it doesn't look like very much of the time, right? That's a small percent. So here we go. I'm going to go back to our normal distribution calculator. We have the mean and standard deviation in already, and we want the percent of time it's above 12. And it shaded that little region, and it turns out it's 0.0228. So this area right here is 0.0228, which is about 2.3% if I round a little bit. All right, and that's a little introduction to how to use the normal curve. So once you get used to deciding what area you need under the curve, we have a tool to find it for us and solve the problem. All right, we're off to a good start. Good luck with this.